In this concept, we're going to talk about adding and subtracting numbers in scientific notation. So we did introduce scientific notation in the previous concept, and now we're going to look at performing operations on numbers written in scientific notation. Now, for addition and subtraction, it's just two simple steps. So you would add or subtract only the coefficients, but the base and exponents have to be the same. Okay, they have to be common. If they're not common, if they're not the same, so if you have two different, exponents, you would essentially have to rename one of the exponents to make it the same as the other exponent. And then you can proceed to add or subtract only the coefficients. Okay, but how do we rename exponents? Well, you increase the exponent by moving the decimal point on the coefficient. Okay, like we discussed in the previous concept again. When you move the decimal point towards the left, you increase the exponent in the positive direction, right? Like you make the number larger towards the positive direction. When you move the decimal point towards the right, you decrease the exponent. You make it negative. Okay, the exponent of the 10, you make it smaller in the negative direction. So again, to summarize this, make sure to apply the rule of a negative and positive exponent when you move the decimal point to the right or to the left of the coefficient, okay, as shown in the previous lesson. Let's look at some examples. So add or subtract the following. So 5.12 times 10 to the third plus 2.8 times 10 to the third. So in this case, the exponents are the same, right? So we have 10 to the third and 10 to the third. So what we do is we just take it common, right? And then it's going to be 5.12 plus 2.8, which gives 7.92. So we just write out the 7.92 times 10 to the third. And this is the final answer. Okay, so again, to recap what we've done, we added the coefficients and we took the common exponent. Again, because we're doing either an addition or subtraction. Okay, and an important check to perform is to check whether your final coefficient and actually the entire expression, whether or not it is in proper scientific notation. In which case, the coefficient a, right, needs to be between 1 and 10, like we talked about in the previous concept when we first introduced scientific notation. In this case, it is, right? 7.92 is between 1 and 10. Right? So this result is fine. Let's look at the next example. 2.5 times 10 to the fourth minus 1.48 times 10 to the third. So right then and there, these two exponents are different. So 10 to the fourth and 10 to the third. Now, the better way to approach this is to rename the smaller exponent to match the larger exponent. So the 10 to the third, the 1.48 times 10 to the third needs to be renamed to something times 10 to the fourth, right? So if I increased the exponent from 3 to 4, that means what does my decimal point have to do here in the coefficient? Well, if I made this larger, I need to make this smaller, right? So 1.48 becomes 0.148, right? So 0.148 times 10 to the fourth. So now I can add it to the initial expression, right? So as you see here, we moved the decimal point one place to the left, right? And then we changed the exponent and we ended up with this number, right? Which is exactly what we had here. And then now the base and exponents are the same, right? 10 to the 4th. So now we just subtract the coefficients. So 2.5 minus 0.148 gives you 2.352, and then just copy the common base and exponent. So the final result becomes this: 2.352 times 10 to the 4th. Okay? Let's look at these exercises. Please pause the video, work on them on your own, and come back for the solutions. Okay, so the goal here is to train further on how to add or subtract the following numbers in scientific notation. So the first exercise is 2.3 times 10 squared plus 4.6 times 10 squared. Right then and there, again, we see that the base and exponents are the same, right? 10 squared and 10 squared. So the result is going to look like this. It's going to have something times 10 squared. So 2.3 plus 4.6 is what? Is 6.9, right? So again, to recap, what we've done is 2.3 plus 4.6 is 6.9, and then 10 squared, remained as 10 squared. So, okay, or we should say, we should just write it separately. So 6.9 times 10 squared. Okay, 6.0 times 10 to the 4th plus 2.5 times 10 to the minus 2. So here the exponents are definitely different. So we have 10 to the 4th and 10 to the minus 2. But again, we have a process that we're following, right? And the process involves renaming, again, one of the exponents to match the other exponent, the other base and exponent. Okay? So in this case, we would rename the smaller exponent, which is minus 2, to get it to match the larger exponent, which is 4. So 2.5 times 10 to the minus 2. If I wanted to make this something times 10 to the 4, what do I need to do? So to go from minus 2 to 4, I'm essentially moving the decimal point by 6 places, 6 positions, okay? To the left or to the right. Think about it. So the minus 2, so to go from minus 2 to 4, you essentially add 6, right? So we're adding 6. So we said that when the exponent is positive, the decimal point is moving towards the left. Okay, it's moving from the right to the left. So 2.5, right? And I have the decimal point here, and to get it to turn 2.5 times 10 to the minus 2 to something times 10 to the 4th, I need to move this decimal point 6 places towards the left. So 1, 2, 3, 4, 5, 6. And then in all these places, I'm going to have zeros. Because, well, that's what it means to move the decimal point to the left or to the right. Okay, every point where there's not a number, or every place where there's not a number, or every position that the decimal point moves where there's not a number, you add a 0. So you have you're going to end up having 0.1234525 times 10 to the fourth. Okay, so again, just to check, we moved this 1, 2, 3, 4, 5, 6. So now we have both numbers having the same base and exponent. So that gives us something times 10 to the fourth, right? And that something is 6.0 plus this whole very small number but having a lot of zeros. So 1, 2, 3, 4, 5, 2, 5. So 6.1234525 times 10 to the fourth. And this is my answer. Okay, next exercise. 4.2 times 10 to the fifth plus 8.2 times 10 to the third. This is to the third. Okay, just in case it's not clear. And this is 10 to the third. Okay. So again, the way to do this is to rename the number that has the smaller base and exponent to have the same base and exponent as the bigger number. Okay, so 10 to the third, I need that to become something to the fifth. So to go from 3 to 5, we're adding 2. So 8.2, right? So again, to make the exponent bigger, I need to make the coefficient smaller. So to make it smaller, I'm moving to the left, right? I'm making it more of a decimal as opposed to more of a bigger number. So 1, 2. So 0.082 times 10 to the fifth, right? So now we have 4.2 times 10 to the fifth plus 0.082 times 10 to the fifth. So again, common base and exponent, 10 to the fifth, and then 4.2 plus 0.082 is equal to 4.2 4.282 times 10 to the fifth. And that's my answer. Next exercise. 6.5 times 10 to the 8th minus 2.5 times 10 to the 8th. Again, this is straightforward because I have the same base and exponent. So I'm just going to write this out, 10 to the 8th, right? And then I'm just going to subtract. I'm going to do 6.5 minus 2.5, and that's going to give me 4.0 times 10 to the 8th. Okay? Very straightforward. Last exercise for this first part of the concept, 9.0 times 10 to the 6th minus 4.5 times 10 to the 5th. So again, you should know this by heart at this point. So rename the smaller exponent. So 4.5 times 10 to the 5th. I need this to become times 10 to the 6th. So if I went from 5 to 6, I added 1 to the exponent. So the coefficient needs to be made smaller So I'm going to move one position to the left. I'm going to move the decimal point one position to the left. Okay, so 0.45 times 10 to the 6. And now I can just add them directly. So times 10 to the 6 minus, or subtract rather. I'm sorry, 0.45 times 10 to the 6. So 10 to the 6 carries over because it's common. 9.0 minus 0.45 is 8.55 times 10 to the 6. And that's the answer. Now, the next part of this concept introduces the multiplying of numbers in scientific notation. And that also includes division. Okay, and division is coming up soon. But for multiplying, you multiply the coefficients and then you add the exponents. Okay, so in this case, the exponents do not have to be the same. In fact, you're going to end up adding them, whatever they happen to be. So there's definitely less steps in multiplying or dividing numbers in scientific notation. So let's look at some examples. 3.42 times 10 to the 8th times 1.1 times 10 to the 5th. So first multiply the coefficients. 3.42 times 1.1 is 3.762. And then add the exponents. So 10 to the 8th plus, or 10 to the 8th times 10 to the 5th is 10 to the 13th. Right? And this must have been a typo. This should be 10 to the 13th. Okay, so 3.42 times 10 to the 8th and then times 1.1 times 10 to the 5th is 3.762 times 10 to the 13th, not 11. Okay, 4.25 times 10 to the 9th, and then the whole thing times 2.7 times 10 to the 12th. Again, first multiply the coefficients. 4.25 times 2.7 gives you 11.45. And then add the exponents, 9 and 12. So 9 plus 12 is 21. So you get 11.475 times 10 to the 21. 11.475 times 10 to the 21 power. However, this answer is not yet in scientific notation since the decimal is not after the first non-zero digit. Okay, so the coefficient A is not between, 10 and 1. So, whereas it has to be between 10 and 1 for the result to be considered, in correct scientific notation form. So we need to change that. So we need to move this decimal point here between the 1 and the 1. So we just made the coefficient smaller in this case, right, by moving the decimal point to the left. So we want to make the exponent larger in exchange. In which case we end up with, if we rewrite this, we end up with 1.1475 times 10 to the 22. Okay, which is the same as what's down here. 1.1475 times 10 to the 22. Now this is correct scientific notation. dividing numbers in scientific notation. Again, very similar to multiplication, but in this case you would divide the coefficients and then subtract the exponents as opposed to adding them. Let's look at some quick examples. 5.2 times 10 to the 7th divided by 2.0 times 10 to the 3rd. So divide the coefficients. 5.2 divided by 2 is 2.6. Subtract the exponents, so 10 to the 7th and then 10 to the 3rd gives you 10 to the 4th, right? 7 minus 3 is 4. And then just write everything in the end. So you end up with 2.6 times 10 to the 4th. Okay. 1.5 times 10 to the 14th, divided by 6.0 times 10 to the 8th. Divide the coefficients. 1.5 divided by 6.0 is 0.25. Subtract the exponents. So 14 minus 8 is 6. So we end up with 0.25 times 10 to the 6th. But again, remember, this is not yet in full scientific notation. The decimal is not after the first non-zero digit. It is after the first 0. Okay, but it needs to be after the first non-zero digit, which in this case is the 2. So the decimal point needs to go here. So I have 0.25 times 10 to the 6th. I need to have 2.5 times something. So since I've made the coefficient larger, I need to make the exponent smaller. So from 6, this is going to go to 5. Okay, which is exactly what we have here. Let's look at these exercises. So here we want to multiply or divide the following scientific notation, the following numbers in scientific notation. Please work on these. Pause the video, work on them, come back for the solutions. Okay, so 1.5 times 10 to the 4th times 2.0 times 10 to the 4th. Very straightforward. 1.5 times 2 and then 4 plus 4. So 1.5 times 2 is 3.0 times 10 to the 4 plus 4 is 8. So 3.0 times 10 to the 8th. 5.1 times 10 squared times 1.2 times 10 to the 5th. So 5.1 times 1.2, again, just to be consistent, this has a underline. So 5.1 times 1.2 is 6.12 times 10 to the 2 plus 5 is 7. That's my result. 4.3 times 10 to the minus 1 times 3.0 times 10 to the 5. Now that gives me, so 4.3 times 3.0 gives me 12.9 times 10 to the minus 1 plus 5 minus 1 plus 5 is 4. But this is not in proper scientific notation. For it to be in proper scientific notation, I need to move this decimal point here. So I need to have 1.29 times 10 to the something. So I made the number smaller. I went from 12.9 to 1.29. So the number became smaller, so the exponent has to be larger. So the exponent has to go from 4 to 5. Right? Which I move, because I moved the decimal point by 1 position. And this is my answer in proper scientific notation. 4.2 times 10 to the 8th divided by 3.5 times 10 to the minus 4. Again, very straightforward. 4.2 divided by 3.5 gives 1.2 times 10 to the 8 minus negative 4, because we have a division, right? So 8 minus negative 4 is 8 plus 4, right? Which is equal to 12. So 1.2 times 10 to the 12th power. 8.0 times 10 to the 12th divided by 4.0 times 10 squared. 8 divided by 4 is 2.0 times 10 to the 12 minus 2 is 10. And that's my result in proper scientific notation. Okay, this is it for this concept. See you in the next video.